Students, Mrs. Fellon here. I am going to go through part of your lesson 4 notes today. We're not going to do the whole thing because there's a few things that I think would just be better if I go over in class. But the beginning part of this I think is kind of enough review where I'm hoping that with this video you're able to kind of understand it and then come back to it and be able to practice on your own. All right, so this first one was kind of designed as a warm-up. So if you want to kind of treat this as a warm-up, you can kind of pause the video and just answer these 4 questions. I'm just asking you which quadrants which quadrants would the angle be located in if this was true? And then the second statement, third statement, fourth statement. So if you want to try this as a warm-up, I would ask that you pause the video, try to answer these questions, then unpause and see if you are correct. Okay, so if you did try this and paused it, what we're basically getting at here is understanding where is sine positive, cosine, or where is sine positive and negative, and where is cosine positive and negative. Same thing with tangent, and then all the reciprocal functions. So remembering that sine is y, okay, and cosine is x. What this is saying is I want sine to be greater than 0. In other words, I want my y value to be positive. So the only 2 quadrants in which your y values are positive are quadrants 1 and 2. And I need my cosine, which is your x, to be less than 0. So that means it needs to be negative. Well, out of these 2 quadrants that are left, the only ones where x is negative would be this quadrant right here. So that is quadrant 2. So the correct answer here would be quadrant 2. For the second one, I want secant to be greater than 0. So secant is positive and negative in the same quadrants as its reciprocal function. So secant and cosine go together. So basically, I want to know where x is positive. Okay, so it's the same thing as saying like where secant is positive is where cosine is positive. So x is positive over in quadrants 1 and 4. And then the second one asks us to do tangent is negative. So remember, tangent is a ratio. Let's put that. Tangent is a ratio of y over x. So in which quadrant would my y value divided by my x value give me a negative answer? And so obviously in quadrant 1, y divided by x would give me a positive answer. So the only quadrant that would exist here would be quadrant 4. The next one, cotangent is positive. So just like secant, its reciprocal function is going to match. Like, so wherever cotangent is positive, tangent will be positive. Tangent is positive in quadrants 1 and 3. And then that's because this is like if your x values and y values are both positive, or if your x values and y values are both negative, y divided by x and y divided by x would give you a positive answer. However, sine is negative only in this quadrant. Sine would be positive up here. So the only quadrant this is going to, where both of these are going to be true, is quadrant 3. In the fourth one, let's go ahead. We are saying secant, which again is the same thing as asking about cosine. Where is cosine positive? Or in other words, where is secant positive? Well, cosine and secant deal with x, so x is positive here and here. This one asks, where is cosine negative? Well, out of these 2 quadrants left, cosine is positive in both of those. So we're down to no quadrants. So in other words, there's no place where secant is positive and cosine is negative. It doesn't exist. Secant and cosine are really the same, have the same positive and negative features as each other. So wherever secant is positive, cosine is positive. Wherever cosine is negative, secant is negative. All right, this is what we did in the previous set of notes, and just kind of reminding ourselves about the side length and about the angle measures and so forth. So 30 degrees is pi over 6, 45 degrees is pi over 4, and 60 degrees is pi over 3. I did have you write down last time like the side lengths, and just as a nice little refresher, a side across from 30 degrees is 1/2. Oops. Across from 45 degrees is root 2 over 2. And across from 60 degrees is root 3 over 2. So you can kind of practice here by saying like sine of your angle, and then kind of, plug it in here. So I'm going to change this to radians, just because last time we did it in degrees. But to be honest with you, nothing really changes. So sine of pi over 6, or sine of 30 degrees, is still going to give me 1/2. This is still going to give me root 2 over 2. This is still going to give me root 3 over 2. And then, as we talked about last time, if I know cosine of pi over 3 is the same as cosine of pi over 6 is the same as sine of pi over 3. Likewise, cosine of pi over 3 is the same as sine of pi over 6. And then if you remember, sine and cosine of 45 degrees is the same answer. Tangent of 30 degrees, or pi over 6, is going to give me that root 3 over 3, and we asked you to memorize those, or I asked you to memorize those. Tangent of 45 degrees, or in other words, tangent of pi over 4, would give us 1. And tangent of 60 degrees would give us that root 3. All right, so what we're going to do next is we're going to practice evaluating with some of the trig functions on the unit circle. What I'm going to have is I'm going to go through a couple of them, and then you guys are going to do the rest, and then unpause the video and see how you guys did. Okay, so, by the way, your notes packet is stapled very weirdly. I don't know how that happened. So, all right, it doesn't really matter. I'm going to do a few of these, so I'll pick a couple that I think are maybe a little challenging. Like we'll do, let's see here, we'll do number 8. I'm going to do 3 of them. Number 8, we'll do number 12, and we'll do number 6. Okay, we'll do those 3, and then I want to have you guys try the other ones on your own. All right, so if you remember what we're doing, we'll start with number 6. We start by kind of drawing your 4-quadrant grid. And the first thing I would do is probably figure out what is 600 degrees. If I subtract 360, I would get 240 degrees. So if it's a coterminal angle, probably the best way to do this is just to go ahead and either subtract 360 from it, or add 360 if it was negative. That way you can get it within one rotation. So determine what quadrant that angle is in. 240 would be in the 3rd quadrant. If this is 240, that means this has to be a 60-degree angle. The side length is root 3 over 2. The side length is 1/2. These two always go together. Both of those are negative in quadrant 2 or quadrant 3, because the x value is negative and so is the y. All right, I am asking you for secant. Secant is the reciprocal of cosine. So if cosine, which is x, is negative 1/2, the reciprocal of negative 1/2 would be negative 2. All right, let's try another one. Tangent of 4 pi over 3. So again, this one's in radians, but I kind of think radians are actually a little bit easier than degrees. So if I had 4/3 of a pi, that's 1 and 1/3 pi. Well, this is 1 pi, and 1/3 pi would land me here. If the denominator is 3, that means my reference angle is 60 again. So this is root 3 over 2. This is negative 1/2, just kind of like the last one we did. And I want tangent. So again, you can memorize that tangent of 60 is going to be root 3. And since a negative over a negative is positive, the answer would be positive. So you could do it that way if you memorize what tangent is. Or you could do opposite, which is root 3 over 2, divided by adjacent, which is 1/2. Negative divided by a negative would cancel each other out. And you will see that those cancel, and then I'm down to just 3. All right, last one. I have cosine of negative 16 pi over 3. So what I did is I rewrote that as negative 5 1/3 pi. So negative 5 1/3 pi. So that means I'm going backwards. So backwards 2 pi, backwards 4 pi, backwards 5 pi, plus backwards another third would land me somewhere in quadrant 2. My denominator is 3, which means this is 60 degrees. Root 3 over 2, negative 1/2. Again, the x value is negative here. Cosine is x, so my answer is negative 1/2. All right, what I have you do is now pause the video, try these 12, or the rest of them I should say on this page, and then unpause the video and check your answers against my key. Okay, so if you've checked your answers, to check your answers, I'm just going to kind of go through answers and then just kind of keep track of the ones you don't understand, and then we can kind of go over those in class. So this answer is going to be 1/2. This is negative 1. This is negative root 2 over 2. This is 1. This is this is positive 1/2, sorry. We already know that one. And then number 7, cosine of 2 pi, I got to equal 1. Jump down to number 9. I got this to be negative root 3 over 3. Cosecant of 5 pi over 3, I got negative 2 root 3 over 3. And then tangent of 5 pi over 2, I got to be undefined. So check your answers. If you don't understand, I would strongly encourage you to maybe ask somebody in class who's gotten it correct. They can kind of show you what they did, and that would be very helpful. All right, let's move on to the next little section. Just so I'm going to just kind of go over this one little last bit, and then we'll kind of move on from there. All right, so on this one, it says we're comparing the relative size of trig ratios. So this is kind of what I'm looking for. We're talking about 40-degree angles and 45-degree angles. So these are not necessarily angles on the unit circle. The 45-degree angle is, but the 40-degree angle is not. But we do know that if I have a 45-degree angle, right? So if I draw a triangle and this is a 45-degree angle, I know that a 40-degree angle is a little bit smaller than that. So because this is a circle, like it's on a, we're talking about, what we're really kind of doing here is this is out here a little bit more. So it's talking about the edge of that circle. So if I have a 45-degree angle and then I have a 40-degree angle, we're trying to think about which one is sine going to be bigger or negative, bigger or less than or equal to. Well, because sine is your y value, and this is 45 degrees, which y value has a bigger difference? Well, if I take the y value of 45 and then the y value of my 40-degree angle, the 45-degree angle will be larger. Okay, let's think about cosine. Cosine is x. So now we're looking at the x value of my 45-degree angle and the x value of my 40-degree angle. So the 40-degree angle I'm going to put as a green triangle, and the 45-degree angle I'll make as a red triangle, so you can kind of see the difference. So if I'm looking at which x value is bigger, well, the green line x value is bigger than the red line. So the 40-degree angle is actually bigger than the 45-degree angle. So the x distance is bigger. For tangent, what you're looking at is tangent of 40, tangent of 45. That is a ratio of y over x. So let's do tangent of 40 in comparison to tangent of 45. Well, tangent of 40 is a small side over a big side. That's how I'm going to write it. Tangent of 45 is a big side over a big side. So this would be like if this is a 40-degree angle, this would, so like these two things would be the same. So tangent of 45 would have to be 1. So that would be like root 2 over 2 divided by root 2 over 2, which equaled 1. Well, because we don't know the exact value of sine of 40 without using our calculator, what I'm getting at here is we know that this side length here is smaller than this side length here. So if I have a number, a smaller number divided by a bigger number, that answer will always be less than 1. So in this case, which one is bigger? Well, the 45-degree angle is going to be bigger because that's going to give me a bigger ratio. So what I'd like you to do, these next ones are kind of the same deal. I just kind of picked different angles. Try to reason about this. This is definitely higher level. I think it's really good for you to kind of think about the ratio of the sides. But try and figure those out. You can stop here though. Part 2 and part 3 of these notes we will do together in class. All right, that's all. Now what I ask that you do for homework is when you get to, so you're going to have a quiz review, so we'll do all this together. On page 21, you should be able to answer all of these questions on page 21. So it's just evaluating, kind of some review of the unit circle stuff, some with radians and so forth. So you should be able to answer all 20 of those questions on page 21, and that's what I want you to complete for homework. I'm also going to give you a quiz review sheet. I would recommend that you do that before the quiz on Monday, just as a review. All right, that's it for now. Bye.